Okay, it's up. Okay, so I'm pretty sure you all have heard the word robot. And what comes to mind when we hear the word robot is going to be this, right? Okay, the transformer or this cute little robot over here. So the main impression we have about robotics is something that looks like a human, okay? But actually robotics is far more than just that. So let us go into dictionary.com, okay? And let's see what are the definition of robotics. First definition is what we are most familiar with, whereby it's about a machine that is, that looks like a human and can perform routine tasks on demand, and that is what we are most familiar with. However, there is a bigger and wider definition is that it is a system that operates automatically. The keyword here is automatically. And so with that second definition, it actually widens the whole definition of robotics. There's also a third definition of a robot, but I think that's not a very flattering description of a person. Okay, so based on that, the definition of robotics that has been enlarged, there's actually a much bigger class of robots. So the one that you are most familiar with on the top left corner, that is known as a humanoid robot. And then if you move to the right, that is a mobile robot, or also known as a wheeled robot. So by that definition of a wheeled robot, your self-driving vehicle, your Tesla, is also considered a robot. And then if you move a bit more to the right, these are industrial robots that work in factories to carry out, manual tasks many times a day. And then at the bottom as well, bottom left, you have a drinks filling machine. It fills up about 100,000 bottles of drinks in a day. And since it performs its task automatically, it is also a robot. And then we have a new trending field of robotics called soft robots. Robots that are built of soft materials, and therefore they can perform different things that the traditional hard robots cannot. So in this bottom middle picture, you see actually three soft fingers being put together to grasp a ball, something that might be difficult for a hard traditional robot. And then at the same time, they can also have, because they are soft, they can also have animal-like properties. For example, we have a snake robot over here, which can go into small into small spaces, or it could even be used for robotic surgery. And then we also have collaborative robots that work together with humans. And collaborative robots must be designed such that they are safe to operate around humans, that they cannot just whack a human and then at whatever force they want to. And then on the right, we actually have what we call swarm robotics. So the picture there shows Olympic rings in the Winter Olympics, in the opening ceremony of one of the Winter Olympics. And this rings is actually formed by hundreds of drones that are working together. And because they are working together, it is called a swarm. So at Monash University, we are also very much involved in the field of robotics, both in our research and our education. So one of the areas that I'm involved in is actually in soft robotics, whereby you have a soft finger over there, and you have a pneumatic air supply at the top. And when air is pumped into the finger, what happens is that it actually starts to bend. And so if you put three of them together, you can actually make a gripper that can actually pick up fragile objects such as eggs, tomatoes, and so forth without damaging them. However, for this kind of robot, it's actually very useful to know how much it is curving, and also what is the force that's being exerted on the object. However, if you want to measure the curvature, if you want to measure the force, then you actually need to put additional sensors on it. For example, if you look at this finger over here, there are actually these black little markers all over it, and we use a camera to capture them. However, these kind of markers could actually make the robot lose its soft properties. It could also add weight to it. So what did we do in our research? We actually use artificial intelligence, and we use the information about the air that's been pumped into, what is the pressure of the air that's been pumped into it, and from there we can determine what is the curvature as well as what is the force that's been exerted. So that if there is an excessive force being exerted, then at least it will just ease on the pressure a little. This is another kind of robot that was designed by one of our PhD students a few years ago, and this is actually an exoskeleton, which is something that the human can wear to assist them in doing various tasks. So for this particular exoskeleton, it is actually to help people with walking disabilities, and it provides support at the crucial parts of their body to enable them to walk properly. And this picture over here shows our undergraduate students participating in a robotic competition, whereby in their second year, one of the subjects that they do is actually a project-based subject, where they need to build robots to actually perform different kind of tasks and compete against each other. So in this particular task, they're supposed to pick up tennis balls and to put it in some holes. So robots actually, can make a good difference in our lives, and they are very good for what we call the 3D jobs. Okay, 3D here does not mean 3-dimension. It actually means the dangerous, dirty, and the dull jobs. So dangerous jobs is, for example, like this robot here that is handling a very hot welding machine. This dirty job over here is where there's a human driver inside a truck, and you have a robotic arm that's picking up rubbish. I think you see this in Australia and UK. And the dull jobs is like the drinks filling machine where you just fill up 100,000 bottles of water in a day. Very tedious, very laborious. And these are the kind of jobs that actually humans don't like to do. And these can actually be used to actually help human lives be better. Okay, so robots can do many things better than humans because they don't get bored, they don't get tired. But at the same time, there are also many jobs that robots cannot do as well as humans. There is this term called Moravec's paradox, where it says that what could be easy for a robot actually could be difficult for humans. But at the same time, what could be easy for humans that we take for granted that we can do easily could be actually very difficult for robots. For example, maybe cutting an apple, cutting a fruit or something like that. And these are things that that a robot might not be able to do as well, or at least the technology has not caught up yet. And therefore, do not worry about robots taking over all our jobs. Robots may take over part of our jobs, but not everything, because there are some things that we just cannot do, or it is just too expensive to for them to do that. So the best way is actually for humans and robots to collaborate together, and that's where we have the term cobot, collaborative robot. And this is one good example of human and robot collaborating together, whereby we have a human driver of the rubbish truck. And at this stage, I think it's still too expensive to develop a rubbish truck that can drive itself, because there's too many legislations, too many laws that they need to get through. And so this is one very good example of a human driver working with a robot to do a dirty job. So now, if you're interested in robotics, what do you need to do? So, well, you can go into various fields. One of them is IT. Okay, you can go into IT because there's a lot of programming involved in a robot to make it smart. And of course, you can go into engineering as well. You can go into mechanical engineering, electrical engineering, because all these are important aspects of a robot. And there's also another kind of engineering called mechatronics engineering. Okay, so at Monash University, we used to be called the Bachelor of Mechatronics Engineering, but now it's called the Bachelor of Robotics and Mechatronics Engineering. And this specializes in learning electrical and mechanical technologies, electronics and AI to and integrate them together to make a nice robot and to make a nice system that can perform automatically. So these are the hard skills involved in robotics. So at your level, at secondary school level, you will need to be good in math and in physics. So you can use that as an indication if you do want to venture into this field. And if you have time, do try to go into a bit of programming as well. For example, there's plenty of free software out there, like for example Python. Okay, there's a very popular free software that you can use, play around with it, and if you do like it, that could actually confirm that whether robotics could be a suitable field for you. Okay, so what I've just mentioned just now are the hard technical skills in robotics, but also do not neglect the soft skills, the emotional quotient. Soft skills are those that see how you actually interact with others, as well as how you interact, how you actually respond to situations. Okay, so important soft skills are going to be communication, teamwork. Communication is important because you need to be able to present your ideas across. As a technical person, as a roboticist, you need to speak to people who know robotics and who know engineering. And you also need to speak to business people, you need to speak to finance people as well. So how do you convince them of your ideas, that your idea is worth investing into? And then another important skill is teamwork, the ability to work together with a group of people. Robotics is a multidisciplinary field involving mechanical, electrical, electronics, and so forth. And it's very difficult for one person to build a nice functioning robot, and therefore it's important to be able to work with teams. When you are in that group of people, does the whole team perform better or worse? And if you have the ability to bring people together, to work together, that will be a very powerful skill, a very powerful quality to have. And finally, do no evil. do no harm. Because whatever technology we pursue, whatever we do, can be used for good and for evil. And so whatever we do can be used for the good of others and can be used to harm others as well. So always remember, in whatever you do, it's always for the good of mankind. So with that, I thank you and I wish you all the very best in your future.